Good afternoon, dear students. Let me continue my class, the EMF of the galvanic cell. Last class, I have mentioned about the sign of the reduction potential. That is the sign of the single electrode potential in terms of reduction. We have seen that the value of the reduction potential changes from minus to plus crossing zero. That is, it means that the value of the reduction potential increases gradually from one metal to another crossing the hydrogen. That is, it is just like the way that the various metal ions are arranged in the orderly manner in the increasing order of their standard reduction potential. This series is known as electrochemical series. Repeat. Okay. The arrangement of various metal ion bar metal in the increasing order of their standard reduction potential is known as electrochemical series. In this series, the position of H plus bar hydrogen is almost at the middle with the value plus or minus 0, while that of highly oxidizable metal ion comes at the top above the hydrogen. They have all negative value of reduction potential, okay, and they are powerful reducing agent generally. So please note, all the metal ion having the negative reduction potential and are more oxidizable than hydrogen and lie above the hydrogen are powerful reducing agent. Okay. The value of the reduction potential of hydrogen is plus or minus 0. That means hydrogen is equally oxidizable and reducible. Okay. Then all other metal ion, the reduction potential value are positive, and that is going on increases and reaches maximum near platinum. Okay, and those metal ion with the positive value of reduction potential are powerful oxidizing agents. They are powerful oxidizing agents since they are easily reducible than hydrogen. Okay, so that is the peculiarity of the electrochemical series. So in the electrochemical series, all the metal ion lie above the hydrogen are powerful reducing agent with the negative reduction potential value, while all the metal ion that lie below the hydrogen are powerful oxidizing agent with positive reduction potential value. Another important of the electrochemical series is that when we couple any two pair of the metal ion in the series, we can assemble or we can design a galvanic cell. And the EMF of the galvanic cell, that is E cell, is equal to E cathode minus E anode. Okay, that is the magnitude of the E cell given out by the particular cell depends on the difference in the cathode potential and the anode potential. Okay, this series is also known as activity series because it is approximately the measure of the reactivity of the metal to undergo oxidation or reduction, hence it is called the activity series. So let us discuss some problem in this connection. Okay, problem number 1, question number 1. You are asked to calculate the standard EMF of the Daniell cell consisting of zinc bar, zinc ion, 1 molar concentration, double vertical ion, copper 2 plus 1 molar copper. Okay, they are the standard states, and you are provided with the standard reduction potential of zinc bar zinc and copper bar copper ion. That is the standard reduction potential of anode and cathode. For zinc bar zinc ion, the standard reduction potential is minus 0.76 volt, and that of copper is plus 0.34 volt. Okay, then you have calculate the EMF of the cell. That's very simple. Only one step is there. Okay. Then I will explain it. Please listen. Please look into it. The equation is E0 cell is equal to E0 cathode minus E0 anode, or E0 right minus E0 left. That is equal to plus 0.34. That is E0 cathode minus 0.76. That is a E0 anode. The answer is plus 1.10 volt. Okay. Always the EMF of the cell is a positive quantity. The next question number 2, you are asked to calculate the EMF of the cell obtained by coupling cadmium and silver in different concentration. Okay, you are given a galvanic cell consisting of cadmium and silver accordingly, in which cadmium is at 0.01 molar and silver ion is at 0.001 molar. Okay, and you are provided with the standard EMF of cadmium, the anode, and standard EMF of the cathode, the silver. As that of the cadmium 2 plus bar CD, standard EMF is minus 0.44 volts, and that of standard EMF of silver bar silver ion is plus 0.80 volt. Okay, please try to carry out the problem. Okay, it involves 3 different steps. That means by applying the Nernst equation, you have to calculate separately the single electrode potential of anode and cathode. Okay, 2 steps: the single electrode potential of anode, the single electrode potential of cathode, then E cell. Okay, so look at it. Please look. That is, first for cadmium 2 plus bar cadmium, that is acting as the anode, the single electrode potential or reduction potential is E0 cadmium 2 plus bar cadmium plus 0.0591 by n log cadmium 2 plus aqua, that is equal to minus 0.44 plus 0.0591 by 2 is the number of electron, log 10 raised to minus 2. The answer is minus 0.4991 volts. Okay, first step. And for the second electrode, that is silver bar silver ion electrode, which is the cathode, Ag plus bar Ag is equal to standard reduction potential E0 Ag plus Ag plus 0.0591 log Ag plus aqua, that is equal to plus 0.80 plus 0.0591 by N1 log 10 raised to minus 3, that is equal to plus 0.6227 volt. That is the second step. Then E cell is equal to E cathode minus E anode, that is equal to plus 0.6277 minus 0.4991. Answer is 1.12 volt. Okay. Then another single electrode, that is a reference electrode, I wish to mention is the calomel electrode. It is a metal, insoluble metal salt in contact with the soluble salt or the soluble salt containing the same anion of the salt. Typical example is mercury, mercurous chloride solid in contact with the aqueous KCl. Okay. This is the calomel electrode. So, calomel electrode is a secondary reference electrode consisting of mercury liquid in contact with the solid mercurous chloride, which is in contact with the aqueous KCl. Depending on the concentration of KCl solution, which is usually 0.1 normal or 1 normal or saturated, okay, have the potential respectively 0.3338 volt, 0.2800 volt and 0.2415 respectively. Once again, if the concentration of the KCl solution is 0.1 mole or normal, then the single electrode potential is 0.3338 volts. And if its concentration is 1 normal, the single electrode potential value is 0.2800 volts. And if it is a saturated solution, okay, saturated, then the value is 0.2415. Usually, a calomel electrode is a combination of mercurous chloride in contact with a saturated aqueous KCl. That is the most commonly used calomel electrode. The electrode reaction involved in it is Hg2Cl2 solid plus 2 electron, giving 2Hg liquid plus 2Cl minus aqua. That means calomel electrode is a electrode that is reversible with respect to chloride ion. That is reversible with respect to chloride ion. Okay, and we have say constant potential depending on the nature or concentration of KCl solution. That is all. The next, coming to the fuel cell, that is very important because it may be a short question or it is most probably is a question for essay question for an examination. The fuel cell. A typical fuel cell is an hydrogen-oxygen fuel cell. The hydrogen-oxygen fuel cell. There are also other fuel cells, that is hydrocarbon fuel cell. There is no need to discuss that fuel cell. For you, the hydrogen-oxygen fuel cell, that is a simple fuel cell that is to be discussed. What is a fuel cell? A fuel cell is a galvanic cell in which the energy of the combustion or energy of the fuel oxidation is directly converted to electrical energy. Okay, that means the energy of the combustion is not converted to heat energy, but instead it is directly converted to electrical energy. That galvanic cell is the fuel cell. A common fuel cell is hydrogen-oxygen fuel cell. The description is it consists of two graphite electrode which is porous and impregnated with impregnated with platinum, powdered platinum inside it. Okay, two porous graphite electrode impregnated with a fine platinum powder. One, the left graphite acting as the cathode, acting as the anode, while the right electrode acting as the anode. And in between the two electrodes, there is an aqueous concentrated solution of KOH or NaOH, which is the electrolyte. Okay. Then from the left side, that is from the to the anode, from the left side, hydrogen gas is bubbled under high pressure, and through the right side, that means the cathode, the oxygen gas is bubbled at high pressure. Okay. The electrode reaction, the whole instrument, the whole apparatus is kept near 60 degrees Celsius under a very high pressure. The electrode reaction involved are at the anode, that is the left-hand electrode, the electrode reaction is 2H2 plus 4OH minus, 4OH minus, giving 4H2O plus 4 electron. That is the oxidation reaction on the left side. On the right side, that is at the cathode, oxygen get reduced with water molecule, that is O2 plus 2H2O plus 4 electron to 4 hydroxyl ion, that is the reduction. The net cell reaction seems to be going to be 2H2 plus O2 giving 2H2O liquid. That means 2 hydrogen molecule combines with the burned in oxygen molecule to produce 2 molecule of water, but electrical energy is produced with an EMF of E cell equal to 1.32 volts. And the schematic representation of the cell is C graphite, hydrogen gas, single vertical line, NaOH, aqua, single vertical line O2 gas, C graphite. So that is a schematic representation. Then some important advantage of this galvanic cell is that, one, it is highly efficient, means the efficiency is more than 60%. Second, it is very light. And third aspect is that here the product produced is water, which is a completely green product, that is water. So it can be used again and again, and is a green product. So it is a cell having no waste or no dust due to the combustion. The product is only water molecule. So that are the importance. That is mean highly efficient, high efficiency, no byproducts, polluted byproducts, and also it can be reusable. That is the main advantage of the hydrogen oxygen fuel cell. Finally, I wish to mention you an important point that I forgot to mention early. That means about the polarity of the anode and cathode of, 2 electrode, 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 2 electr Okay, that is the polarity of the anode and cathode of the galvanic cell. I wish to mention, normally an anode is defined as that electrode which undergone oxidation, while cathode is defined as that electrode which have undergone reduction. Okay, we have a notion that anode is positive and cathode is negative. It's a general notion that have with us. But the case of a galvanic cell, that's different. The anode here is negative in polarity due to the accumulation of the liberated electron on the surface of the anode. Okay? That is, the anode is negative in polarity in a galvanic cell due to the accumulation of electron on the surface, while the cathode is positive. Well, the cathode is positive here due to the consumption of electron or the deficit of electron that occurs around the vicinity of the cathode. That occurs around the vicinity of the cathode. So, once again, in a galvanic cell, the anode is negative in polarity and cathode is positive in polarity against the normal notion. Okay, thank you very much. I hope that most of you have followed my class. Please try to carry out the problem, more number of problem, so as to make the subject more thoroughly. Wish you good luck.